Welcome, students. In this lecture, we will dive deep into Chapter 3, Chemical Bonding. This is a really fundamental chapter in chemistry. It explains the very reason why atoms don't just float around by themselves. We'll explore why they combine, how these chemical bonds actually form, and we'll look at the different types of bonds that create all the amazing compounds we see in the world. So, let's get started. First up, what exactly is a chemical bond? Think of it as a special kind of glue. A chemical bond is the force of attraction that holds atoms together, allowing them to form larger structures like molecules or compounds. Without bonding, atoms would just exist as separate, individual particles. We wouldn't have water, we wouldn't have salt, we wouldn't even have the air we breathe. Bonding is what allows stable substances to exist. So, the big question is, why do atoms even bother to form bonds? The one-word answer is stability. Most atoms are inherently unstable when they're in their free individual state. They have this natural drive to achieve a more stable arrangement for their electrons. What's the most stable arrangement? It's the one that noble gases like helium, neon, and argon have. These elements are superstable because they have a full outermost electron shell. All other atoms want to be like them. This leads us to a very important principle called the octet rule. The octet rule states that atoms tend to gain, lose, or share electrons in order to have 8 electrons in their outermost shell, also known as the valence shell. Achieving this octet of electrons makes the atom stable. There are a couple of small exceptions, like hydrogen and helium, which are happy with just 2 electrons. They follow what we call the duet rule, but for most other atoms we'll discuss, 8 is the magic number. Now, how do atoms achieve this stable octet? They do it by forming chemical bonds. There are 2 major types of chemical bonds you need to understand for this level: ionic bonding and covalent bonding. Each type is formed in a very different way, and it depends on the kinds of atoms involved. Let's break down each one. Let's start with ionic bonding. The key word here is transfer. Ionic bonding involves the complete transfer of one or more electrons from one atom to another. This type of bond typically occurs between a metal and a nonmetal. What happens is the metal atom gives away its outer electrons and becomes a positively charged ion called a cation. The nonmetal atom then accepts those electrons and becomes a negatively charged ion called an anion. It's the strong electrostatic attraction between these opposite charges that creates the ionic bond. A classic everyday example is the formation of table salt or sodium chloride, which has the formula NaCl. Sodium, a metal, has just 1 electron in its outermost shell. It's much easier for it to lose that 1 electron than to gain 7 more. So it gives that electron away and becomes a positive sodium ion. Nara. Chlorine, a nonmetal, has 7 electrons in its outer shell. It just needs one more to complete its octet, so it eagerly accepts the electron from sodium and becomes a negative chloride ion. Cl. The powerful attraction between the positive Na and the negative Cl forms the strong ionic bond in sodium chloride. Because of this strong attraction, ionic compounds have some very distinct properties. First, they generally have very high melting and boiling points. It takes a lot of energy to break those strong ionic bonds. They are also typically hard and brittle crystalline solids at room temperature. Think about a salt crystal. A very important property is that they can conduct electricity, but only when they are molten or dissolved in water. In a solid state, the ions are locked in place, but when melted or in a solution, the ions are free to move and carry an electric current. Finally, most ionic compounds are soluble in water. Now, let's move on to the second type, covalent bonding. If ionic bonding was about transferring electrons, covalent bonding is all about sharing. A covalent bond forms when two atoms share electrons instead of completely transferring them. This type of bonding usually happens between two non-metal atoms. When they share a pair of electrons, that shared pair constitutes one covalent bond, holding the two atoms together. Let's look at a simple example. The hydrogen molecule H. A single hydrogen atom has only one electron. To become stable, it wants to have a configuration like helium, which has 2 electrons. So, when two hydrogen atoms come close, they can each share their one electron with the other. By sharing this pair of electrons, both hydrogen atoms feel like they have 2 electrons in their outer shell. This sharing creates a single covalent bond and forms a stable hydrogen molecule. Another great example is the water molecule. HO oxygen has 6 electrons in its outer shell and needs 2 more to complete its octet. Hydrogen, as we know, needs 1 more, so an oxygen atom will share electrons with 2 separate hydrogen atoms. It forms one covalent bond with the first hydrogen and a second covalent bond with the other hydrogen. This allows the oxygen to complete its octet and both hydrogens to complete their duets, creating the stable V-shaped water molecule we all know. Just like ionic compounds, covalent compounds also have a set of general properties. In contrast to ionic compounds, they tend to have low melting and boiling points because the forces between the molecules are weaker. They generally do not conduct electricity in any state because there are no free-moving charged particles. They are often soft solids, liquids, or gases at room temperature. Think of methane gas or liquid water. And many of them are insoluble in water, though there are exceptions like sugar and water itself. So, let's quickly summarize the key differences to make sure it's clear. An ionic bond involves the transfer of electrons, usually between a metal and a nonmetal. A covalent bond involves the sharing of electrons, usually between two nonmetals. As a result, ionic compounds typically have high melting points and can conduct electricity when molten or dissolved. Covalent compounds, on the other hand, have low melting points and do not conduct electricity. And that brings us to the end of our chapter summary. In this lecture, we learned what a chemical bond is and why atoms form them to achieve stability, guided by the octet rule. We explored the two main types: ionic bonding, which is about transferring electrons, and covalent bonding, which is about sharing electrons. We also looked at their properties and key differences. Understanding these fundamental concepts is crucial because it helps explain how literally all the substances around us are formed and why they behave the way they do. Thanks so much for watching. I hope this lecture was helpful. If you found it useful, please give it a like, share it with your friends, and don't forget to subscribe to the channel for more chemistry lectures. See you in the next video.